All right. Good morning, good afternoon, good evening. Welcome once again to my presentation. Today, we shall be exploring the pedagogical differences in media selection. My name is A.Kaburi. So, um, when we talk about pedagogical selection, by way of introduction, we would like to look at pedagogical differences between technology and or media. And then we'll also be looking at the sections framework that will help us to make the right choice in terms of media selection. And finally, we shall be exploring the applications to physics teaching in our physics classroom. So this diagram here tells us that it gives an overview of how the things to consider if we want to make choices as with regards to the kind of technology that we want to use in our classrooms. So the technology here refers to the kind of technology. So we want to consider the design of the technology, how it does evaluation, how to implement it, as well as the kind of assessment that it allows. And the learning aspect is talking about we implementing it in our teaching and learning. How is it going to help in our delivery? And how is it going to help in the definition of concepts and application in terms of conceptualization? So this is a brief introduction about what we are going to look at and an overview of the things that we are going to explore in this our model today. So for us not to waste time, we want to first of all look at the framework for coherent thinking. And to make it very simple, we have had this organogram or simple uh, diagram showing us that the three things that we need to consider in terms of our framework is that for us to look at to take a decision as to which kind of technology to use. Number one, we need to consider the tech affordances. Number two thing that we need to consider is the instructional benefits of that technology. And the third one, or the last thing we need to now consider is the instructional strategies that can help us or be merged into this technology to make sure we achieve our end goal. So someone may ask that what is the tech affordance? So the tech affordances are the potentialities or the functionalities or the capabilities of the technology in question that what it offers in our instruction. And the instructional benefits are the advantages or the positive outcomes for both teachers and students that will result from the utilization of this technology. And the last thing, that is the instructional strategies, are the deliberate instructional approaches and methods that may be used by you as a teacher to leverage the affordances of the technology to achieve our instructional benefits or our end goals. Now, for us to move ahead, we want to compare do a comparison of our media or the various technology that can be used in our teaching and learning or in our classroom. And for us to do that, we can never do away with the four theories of learning, which are the behaviorism, the cognitivist, the social learning, as well as the constructivist. So we are going to look at those four learning theories and how the individual or some of the technologies that we use in our classrooms are affiliated to this kind of learning theories. So the number one is the Canva, which is the medium. The medium is the LMS, or an example is the Canva. And the theory that this falls under is the cognitivist. And the tech affordances are that we have a structured content delivery and we have availability of assessment tools that can be used in the Canva for our assessment during our lessons. And the instructional benefit is that we have an organized curriculum flow and we can also have a self-paced learning. And when we come to simulation, which is the medium, we also have the learning theory that is falls under is the constructivism or the constructivist learning theory. And the tech affordances is that it has real-time experimentation, so we can do different kinds of experiments when it comes to our simulation. And the instructional benefits that we get from this learning medium or learning constructive learning theory is that we get conceptual understanding of abstract phenomena from this simulation. An example is the physics educational technology platform or project. And the last one is the AR or the VR, which uses a learning theory, the learning theory of experiential learning, which we explored in our previous model a lot about what experiential learning, learning by experience, learning by doing, or learning by engaging. And the tech affordance in this medium is that we have immersive or spatial interaction. And the instructional benefits that we can get from this is that it enhances our engagement because we have been made to know that experiential learning theory involves learning by activity, learning by hands-on doing, and learning by engagement of learners between learners themselves and the learners and the teachers. And it also embodied cognition. So these are some of the tech affordances of a few learning medias, and the learning theories that they fall under their tech affordances and the instructional benefits. So for us to make any kind of selection or choice of our media or technology to use, these are the things that we need to consider. And we're taking this the three of them for the purpose of this model. So let's move ahead. Now we want to, sorry. So now I want to look at what our tech, or want to look at what this is, FET. What is the FET? What is the FET? So the FET is generally or originally called the Physics Educational Technology. And it has a lot of interactive sims for science education. And it's a research-based project which is user-friendly, and it has been tested by research. Several institutions around the world have used it, and it has been well tested to be one of the best in terms of science teaching. And this can be run both in offline and online. And even though it's a physics educational technology, it can be used for even in math, chemistry, earth science, and biology. And the good thing about it is that it's free, and the source code is readily available. So, well, knowing that, how having that in mind, let's focus on the simulation in physics education. So the technology that we are talking about is the physics educational simulation, which we usually refer to as the PHET simulation. And like we mentioned, we need to consider the affordances, state instructional benefits. Then we now move on to the kind of approach or instructional strategies to use. So the tech affordances is that this technology is manipulative. You can manipulate different variables. It gives immediate feedback, and it's safe and repeatable environments that you can do it over and over again. And the instructional benefits is that it deepens conceptual understanding, not just abstract, but it deepens conceptual understanding. Also, it promotes inquiry-based learning. And the last thing is that it supports visual and kinesthetic learning. So it cuts across different kinds of learners because our classroom will have different kinds of learners. And if we have a technology that is able to cover all the kinds of learners, then it's something that is worth using. And for example, we see here we have V is equal to IR, which is basically an Ohm's law. And we can simulate this in our physics educational technology model by indicating how when we say something is equal to, then we are saying that it's directly proportional. So if we can simulate in such a way that we see that once this is the voltage, this is current, and this is resistance. So we can do our simulation to see that when the voltage is increasing, our current is increasing, and our resistance is also increasing. And of course, we can make I the subject, and then we have V in. I is equal to V over R, which shows that I is now inversely proportional to R. So when one is now increasing, one is now decreasing. So this is a bit of physics or bit of science, and it's only maybe those of us who are into science that may understand it. So let me not waste your time so much about this. But what I want us to understand is that this particular technology is manipulative. It's something that is user-friendly, and it deepens conceptual understanding, and it promotes inquiry-based learning. Now let's look at instructional strategies. Like I said, that is the last thing that we have to always consider when it comes to the things that we consider before we make a choice of technology to use. So before we do our simulation, like we are using the physics technology, educational technology system, we doing that before our simulation, we need to do predict, observe activity to make sure that we brainstorm our learners to know what they know and to be able to do some kind of explanation before we do it. We go into our lesson. And during it, we have to do a guided inquiry using scaffolding questions to get a deeper understanding of what they are doing. And after, we do reflective journaling, either in group or as individuals in a classroom. And by doing all this, we will now align with our practices and help us to have proper data analysis and report writing. Now, sections model. So this is the sections framework, and the sections framework is also a tool that helps us to make right decisions when it comes to the kind of technology to use. And what is the sections model? So the sections model is divided into different sections, and the sections, S stands for students, E stands for ease, C stands for cost, T stands for teaching and learning, I stands for interactivity, O stands for organizational issues, N novelty, and S is speed. So we need to know the kind of students that we are working with, or we are using this technology on, how it is appropriate for this particular group. And when it comes to the easiness or the reliability, we need to know that the students must be able to use the technology without difficulty. They must be able to, will it distract their actual learning? We have to ask all these questions. What is the cost? How much is it going to cost either the classroom, the school, the institution, or the users themselves? Is the teaching and learning part? What instructional needs are there? What kind of students' need do we want to solve or do we want to achieve? And is it the best for that particular need? Interactivity. What kinds of interactions does the technology allow? Organization. Are there organizational requirements? Are there things that we need to remove? Are there things that we need to amend? What are the things that we need to do as an organization? Novelty. Is the technology new? Has it been tested and proven by research and other users? What are the reviews on it? These are the things we need to ask. Speed. How quickly can the technology be implemented? How feasible it is? Is it? Can it quickly change or meet the requirements for us to be able to achieve our end goals? These are some of the things that we need to questions that we need to ask in the sections model. And if you're able to answer all these questions correctly and do the plus and minuses, then we should be able to make the right choice of technology to use in our classroom. Now, so this is generally one of the some of the phases of how the physics educational technology look like, where you can register as a teacher, you can play with the simulations, and you can also register if you don't have an account. You can do your simulations, teachings, research initiatives, and so on and so forth. And we can see here that over 1.5 billion simulations have already been delivered. And this does not only cover physics, but we also have chemistry, we have earth science, we have math, and biology. So if the students have this platform, like we said, we have to know whether it's accessible to them. And this simulation is accessible, it's easy to use, it's free of charge, and it's open source. It aligns with inquiry-based pedagogy. It's highly interactive. It's easy to integrate into classroom. Its novelty is that it stimulates curiosity. It's quick to load and adapt, can easily be adapted in the classroom. Now, reflection on pedagogical coherences. So we must tie this back to our initial process that we talked about, that reflection serves as a center. So as we are reflecting, we are thinking about the kind of students, the faculty, or the skills that we have as teachers, and the kind of assessment that we want to achieve or want to assess our students on. So we choose simulations because of the affordances. It's interactive, it's visualized. Its institutional benefits is that it's engaging and understanding, and it's matched with inquiry-based strategies. And this supports the sections, or the section model also support it. It's supported by the sections model for teaching of physics. That is why we chose this particular technology. Now, our key takeaways. Key takeaways. So the key takeaways is that we need to understand is that, or we need to take from this as a way of summary of this our model is that different technologies or technology models have different learning theories and pedagogical goals. Number two, we need to understand is that effective teaching with technology requires understanding and its unique features or affordances for matching them with our appropriate instructional strategies. We need to make sure we apply the sections framework which help us make informed decisions with regards to the context or make decisions with regards to the kind of technology to use. And our pedagogical coherences must align with the affordances of the technology and the benefits as well as the strategies for us to have an essential and a meaningful learning, teaching and learning or classroom activity. So this is the end of my presentation, and these are the references that I use for preparing this my model. Thank you so much for listening to me, and if you have a question, you are free to let us have a discussion in the discussion forum. Thank you very much.